Today we will talk about Leetcode question 146, LRU cache. I think this question is quite popular problem during the interview, so I would like to share how I understand this question. So first, what is LRU cache? So LRU cache is the least recent used cache. So given a cache, usually a cache has certain capacity, means how many elements it can hold. So for instance, if it can only hold two elements, for instance, it can only hold two elements, then if the third one comes, we need to decide which one to pop out of the cache. So in that case, we need to decide whether we want to pop out the least used one or most used one. Okay, so that is a kind of design issue when we try to design the cache. So in this problem, it asks us to design a least recently used cache. That means which element that we least used will be popped out from the cache. So it has three functions. Actually, one is the initial function. The other two are the actual functions. And first, during the initial function, it gives a capacity called int, which means we will initialize the LRU cache with the positive capacity. So here at first, I thought maybe I can use some array or some dictionary with the capacity. However, it's not necessary. So we don't need to initialize some certain data structure with the capacity. However, we can use some counting, such as the count, to count how many elements or how many slots that are available for holding the new element. So here we can use some count to hold the capacity, right? And then since it's overall, it is the data structure should be like a dictionary. Well, if the key is in the dictionary, we will return the value of the key. Otherwise, we will return -1. And then if we update the dictionary, then we will put a new key and value in the dictionary if the key exists. Otherwise, we will add a key value pair to the cache. And also, if the number of keys exceeds the capacity, then we will pop out one element which is the least used element in the dictionary. So we have to use a way to keep track of what is the least recent used key. And also the put and get should return in constant running time. And also there's the key and value is larger or greater than 0 and less than certain value. Okay, so now let's see how we can design this data structure. Since the overall data structure should be like a dictionary, then we need to design a cache like a dictionary. However, in the Python, there's a data structure called ordered dictionary. So we can use the ordered dictionary to hold the elements in the cache. Because ordered dictionary can have special functions, such as we can move certain element or certain key to the end of the dictionary. So comparing to the normal dictionary is more powerful. So in this part, if we check certain key is in the element, if it's not in the self.cache, we will return. Otherwise, we need to first get the value of the current key, and second, we need to move the key associated with the value to the end of the cache. So in that case, there are two steps. First, we need to return the value of the current key and then that is the record we need to return. And then the next we need to pop the key from the beginning of the pop the key from the dictionary and insert the key to the end of the dictionary. So self.cache.pop. First we pop the key and then we put the key to the end of the dictionary. And then these two steps can be also be done by a move to end function within this ordered dictionary list. The ordered dictionary, sorry. So, but this one just to make the process more clear to you. When I first get the value and then pop the key and then store the key associated with value to the end of the dictionary. And if we want to put some key together with the value in the dictionary, we first want to check if the key is in the dictionary, right? So first we want to check if key is in the self.cache. If the key is in the self.cache, then we want to pop the key first together, the same with this one. And then we want to move the key together with the value to the end of this dictionary, right? But if key is not in the dictionary, then we need to have different conditions. First, we haven't met the capacity of the cache. That means if self.count is still larger than 0, that means we still have available slots to hold the new key, then we just update the self.cache key equals to value, right? So, but in this case, we need to update the self.count -1, right? This is if statement. Else, if self.count equals to 0, that means we need to pop up the least used element from the dictionary. In this case, we will use self.cache.pop item. Here we want to pop from the beginning of the dictionary, so we will use last equals to false. That means we pop from the beginning, otherwise last will be equal to true. So this is the whole process. We first run from here. Okay, evaluate if key not in self.cache. Value is not defined. Oh, okay. Okay, this should be the rest. Okay, now it passed the example, and then we try submission. Okay, hopefully you enjoy the whole problem. Thank you for watching.